Hello, welcome to SS Section 1. Today we'll be teaching you, yes, you, all about ciphers. But no, not just any cipher, a very special one, the Caesar Cipher. Now, what is a cipher? Ciphers are encoded writings that are meant to hide secret messages, but the Caesar cipher is no ordinary cipher. No. It's a shift cipher, meaning that you would move all the letters in the message by an A multiplier or B shift. Now, this might sound foreign to you now, but after this video, you will be able to understand what I just said.
Well, hello. So let's begin with a little bit of history and background about the Caesar cipher. Let's go to Caesar himself to let him explain.
I came, I saw, I conquered. I am Julius Caesar. As the brilliant general I am, I know communication is very important. This precious information, however, is easily stolen and intercepted. Therefore, in times of war, like the Gallic War, when spies and such are lurking around, I utilized my famous cipher. This cipher saved my plans time and time again, as enemies dismissed my writings as gibberish.
So how do you actually use this cipher? Well, the Caesar cipher revolves around the idea of using a numerical alphabet. This means that each letter is assigned to a numerical value.
Generally, A is assigned to 0, B is assigned to 1, C is assigned to 2, D is assigned to 3, and so on until Z, which is 25.
After using it to convert your messages to numbers, you can apply a B shift or an A multiplier. Now let's go over the doodle board to find out what those are.
A B shift value is a number that you add or subtract to a numerical message. A right B shift would be addition because you are moving to the right on the number line. A left B shift would be subtraction because it would move to the left. For this example, we'll be using hello or 7, 4, 11, 11, 14. We will apply a right B shift of 3 which adds 3 to the message. You would get 10, 7, 14, 14, 17, and if you change it using the numerical alphabet, you would get KHOOR. If you use the left B shift of 3, you subtract 3 from all the numbers, you get 4, 1, 8, 8, 11, or EBIIL. You can probably already guess what the A multiplier does. That's right, it multiplies your numbers. Let's use hello again and use the A multiplier of 3. You would get 21, 12, 33, 33, 42, which would be VMHHQ. Now you may have already noticed, but 33 and 42 are not in the numerical alphabet. When this occurs, you use what is called modular, or mods. The Caesar cipher uses mod 26, which means that you would divide the number by the mod value, in this case 26, and you would use the remainder. So if we multiply this again, 21 is V, 12 is M. If you divide 33 by 26, you get a remainder of 7, or H. And if you divide 42 by 26, you get a remainder of 16, or Q. Mods can also be used for B shifts when your sum is greater than 25. Let's use hello again. If we use a right B shift of 13, we would get 20, 17, 24, 24, and 27. Because 27 is not in the numerical alphabet, we can use mod 26. If you divide 27 by 26, you could get a remainder of 1, or B.
But wait, there's more!
Wait, what?
You can also apply a few rules to these ciphers. Let's go back to the doodle board to explain these.
Now, it would be really easy to decipher a message if it had single letter words, because the only single letter words in English are A and I. Because of this, one of the rules is you have to group all the letters into 5-letter group. So this message would actually be this message. You may have noticed this rule already, but you must also capitalize all the letters in the encoded message. This is because there are very few words with a capitalized I, so it'd be very easy to guess.
So what if you weren't Caesar? Instead, you were his deadly foes trying to decipher his messages? Well, the cipher isn't as amazing as it seems, and it is easily deciphered. Let's go to the doodle board. Since the B shift uses either addition or subtraction to encode, you can use the opposite operation to decode it. Let's use the right B shift of 3 for hello again. Because 3 was added to the message to get KHOOR, which is 10, 7, 14, 14, 17, you can convert the message back into numbers and subtract 3 to get 7, 4, 11, 11, 14, and then convert it back into letters to get hello. If you have a left B shift of 3, you will simply just add 3 to the encoded message. Decoding an A multiplied message is a little more difficult because there could be mods. To decipher it, you can continuously add the mod value 26 to the number until it is divisible by the A multiplier. Let's use VMHHQ, which is 21, 12776 with an A multiplier of 3 again. If you decipher it, you would get hello, which would be 7, 4, 11, 11, 14.
So if you want to find out all these juicy secrets, but you didn't know the B shift or A multiplier, what can we do in order to decipher this encoded message? One of the easiest ways, but most time consuming, is the brute force method. Now what we do here is we simply call what we call guess and check until we find a cipher that works. Of course, this is incredibly inefficient. So another example of what we can do is the frequency analysis. And we're gonna show this on the doodle board right now. So let's go back to that real quickly.
Basically, you find the letters that occur the most or least often in the encoded message so you have a better idea of what they might be. For example, in this message, the H is the most common in the message, so it's likely to be an E, so the shift could be a right B shift of 3.
Let's go quick quiz. All your books away and let's decode this message. You have 1 minute. Go.